So previously in our course, we were able to use our trig ratio, sine, cosine, or tangent, to write expressions about this angle theta and our given sides. So in this first triangle here, right, with our angle theta, we have an adjacent and a hypotenuse, and so we can say that cosine of theta is equal to 6 over 22, right? And then in this bottom triangle here, we have opposite over hypotenuse, so we would say that sine of theta is equal to 50 over 60. Now that was kind of nice because we could write a trig ratio, and we also knew that we could use the Pythagorean theorem to find the third side if we really wanted to. So there's a variety of things that you could have done, right, to help you find the sides. But if you really wanted to find what theta is, or the complement of theta, at this point we didn't really have anything. So like we talked about in class today, we could use the inverse trig functions, right? So since cosine is a function, to undo cosine, we take the cosine inverse of that entire side. And what we do to one side, we have to do to the other. So inverse cosine and cosine are inverse functions, so what you're left with on the left-hand side here is theta. And so theta is the inverse cosine of 6 over 22. And at that point, I can just type that into my calculator. Let me bring that over here. Oops. It's not what I want it to do. Here we go. You can see my calculator in the screen. So now I hit second and cosine. That gives me inverse cosine of 6 divided by 22. And round it to 2 decimal places. That's 70.17. And that's an angle in degrees. So this angle here is 70.17 degrees. So that means that this angle here is just under 20 degrees, right? So the inverse cosine, or this statement here, says that the inverse cosine of the ratio 6 over 22 is 70.17 degrees. In other words, the angle whose cosine is 6 over 22 is 70.17 degrees. Okay. Similarly, if we look at our problem down below, we know that sine of theta is 50 over 60. Well, to solve for theta, I inverse sine both sides to get the theta by itself. And so that tells me that theta is equal to inverse sine of 50 over 60. If you really wanted to, you can simplify that to 5 over 6. Doesn't really matter. Inverse sine of 50 divided by 60 is 56.44. Okay, so the angle whose sine is 50 over 60 is 56.44 degrees. This angle right here is 56.44 degrees. I have an expression on sine inverse of 0.2. If I wanted to evaluate it, what that means is that I plug that into my calculator and I find inverse sine of 0.2. And my answer is 11.53, I believe, right? 11.54. 0.54 degrees. Okay. If I want to draw this, right, if I want to sketch a right triangle, this corresponds to 23 to 28 in your book, sketch a right triangle to illustrate. Let's take a look. Okay, so I know that my ratio of opposite over hypotenuse is 0.2. What angle is it? It's 11.4. So this is my 11.54 degree angle, and I know that my opposite over hypotenuse has a 0.2 ratio. So I can say that this is 0.2 and this is 1. If I wanted to, I could say this is 2 over 10. Whatever, it just has to be that my opposite over hypotenuse is equal to 0.2. And so, just to recap, right, because you're going to be asked to evaluate and then sketch. Evaluate means plug it into your calculator, what is it equal to, right? So I know that the inverse sine of the ratio of 0.2 is an 11.54 degree angle. And then to sketch what that looks like, it's this, right? I have an angle here that's 11.54 degrees, and my sine of that angle is 0.2, which is 0.2 over 1. Okay? And let me just write this in so you can see. Another choice that you can make, right, because the similar triangle is 2 over 10, right, because 2 divided by 10 is also 0.2. And that's using the idea of similar triangles.